Today, we will be talking about Mathematics 7, Quarter 1, Week 4. Competencies. Illustrates the different properties of operations on the set of integers. Expresses rational numbers from fractional form to decimal form and vice versa. Objectives. Identify the different properties of addition and multiplication of integers. Appreciate the importance of expressing rational numbers from fractional to decimal form and vice versa. Convert fractional form to decimal form and vice versa. Topics: properties of addition and multiplication of integers. Convert rational numbers from fractional form to decimal form and vice versa. First, let's talk about properties of addition and multiplication of integers. The pictures shown are the properties of addition and multiplication with its descriptions and example. Let's focus on the properties of addition of integers. And the first property is the commutative property. Of addition. So, commutative property of addition states that changing the order of addends does not change the sum. So, even if we change the order of the addends, the sum doesn't change. Example. So, these numbers are the addends. The result will be the sum. So, if we change the order of the addends, like 2 plus 3 becomes 3 plus 2, the result is still the same. So, 2 plus 3 is 5, while 3 plus 2 is 5. So, that is an example of commutative property of addition. Second property is the associative property. Associative property of addition. So, associative property of addition states that changing the grouping of the addends does not change the sum. So it means even if the addends are interchanged, the sum will not be affected. So examples: so in the left side, the following numbers that are grouped is negative 2 and positive 5. While on the right side, the numbers that are grouped is 5 and 4. So, even if they have different groupings, the result is still the same. Why? Because they have the same numbers on each sides. So let's compute. Negative 2 plus 5, that is equal to 3. 3 plus 4 is 7. So the result here is 7. Let's see if the result on the right side is 7. So, first solve the innermost or the numbers inside the parentheses using PEMDAS. So 5 plus 4 is 9. Next, negative 2 plus 9, that is equal to 7. Very good. So on the left side we get 7, while on the right side we got 7. They are the same. Next example. So next example is 1 plus the quantity of 3 plus 6 is equal to the quantity of 1 plus 3 plus 6. So here, let's see if the left side is equal to the right side. So in the left side, what is being grouped is 3 and positive 3 and positive 6. While on the right side, what is being grouped is 1 and positive 3. First, using PEMDAS, let's solve the innermost equation. Our numbers, 3 plus 6 is 9. And 9 plus 1 is 10. So on the left side, that is equal to 10. Let's see if it is equal with the right side. 1 plus 3 is 4. 4 plus 6 is 10. So they have the same answer or sum, which is 10. So we are correct. Next. Now for the third property of addition of integers is the additive identity property. Additive identity property states that adding 0 to any number does not change the value of the number. So, any number that is being added by 0, that number will not be changed. Example, 6 plus 0. 6 plus 0 is equal to 6. So the number 6 will not be changed. Other example, negative 1000 plus 0 is equal to negative 1000. Still, the number will not be changed if it is being added by 0. The next property is called the additive inverse property. So, the additive inverse property or the inverse property of addition, the inverse property or the inverse property of addition states that the sum of any number and its additive inverse is 0. So, when we say additive inverse, that is the number that will make that number 0. So, for example, we have 6. The additive inverse of 6 is negative 6. So, when you add that one, the answer will be equal to 0. Or when you subtract that one, the answer will be 0. Another example, the additive inverse of negative 10. The additive inverse of negative 10 is positive 10. So, negative 10 plus 10, that will be equal to 0. By the way, the other name for additive identity property is called the identity property of addition. Now, let's proceed to the properties of multiplication of integers. The first property that we will be talking is is the commutative property of multiplication. So just like with the properties of addition, the commutative property of multiplication states that changing the order of the factors does not change the product. So even if we change the order of the numbers to be multiplied, the product will still be the same. Example, 3 times 4 is equal to 4 times 3. Why? 3 times 4 is 12, while 4 times 3 is still 12. So even if we change their order, like here, the first number is 3 followed by 4. And the other one, the first number is 4 followed by 3. They will still have the same answer or product. Other example, we have negative 5 times 10, that will be equal to 10 times negative 5. So the answer here is negative 50, while the answer on the right side is also negative 50. They will still have the same product. Now let's proceed to the next property. The next property is the associative property of multiplication. So here, just like with the addition properties, it states that the changing of the groupings of the factors does not change the product. So even if we change the groupings of the numbers with the factors, still their product will still be the same. Example, we have 2 times 3 times 4 is equal to 2 times 3 times 4. Why? Because the result here will be equal with the result here. Let's see. 2 times 3 is 6. 6 times 4, 6 times 4 is 24. So 24 is the product on the left side. Let's see if the result on the right side is 24. 3 times 4 is 12. 12 times 2 is 24. So the result is still the same. Let's have another example. Negative 5 times 3 times 5 is equal to negative 5 times 3 times 5. So here, what is being grouped was 3 and 5. While on the right side, what is being grouped is negative 5 and 3. Let's see if their answers are the same. So here, 3 times 5 is 15. 15 times negative 5, that is equal to, again, negative 5 times 15, that is equal to negative 75. So let's see if the answer on the right side is also negative 75. Negative 5 times 3, that is equal to negative 15 times 5, the answer is negative 75. So, because they have the same answer or the same product, it means that this one is an example of associative property of multiplication. Now, the third property is the multiplicative identity property, or it is sometimes called identity property of multiplication. So, the multiplicative identity property or the identity property of multiplication is just the same, and it states that multiplying 1 and any number does not change the value of the number. So it means any number being multiplied by 1 will always be equal to itself or to the number that is being multiplied to 1. Examples: negative 25 times 1 is equal to itself, which is negative 25. How about 1 over 10 times 1? That is still equal to itself, which is 1 over 10. So, let's have the next property, which is called the multiplicative inverse property. Or it is sometimes called inverse property of multiplication. So, multiplicative inverse property or the inverse property of multiplication states that the product of the number multiplied with its reciprocal, it is equal to 1. When we say reciprocal, that is this one. If we have a number 9, the reciprocal of number 9 is 1 over 9. So it means 9 becomes the denominator of a fraction and the numerator becomes 1. So 9 and its reciprocal will be multiplied. The result will be equal to 1. So let's have another example. How about 5? 5 multiplied with its reciprocal, which is 1 over 5, the answer is 1. How about we have 1/2 times with its reciprocal, the reciprocal of 1/2 is 2. So 2 in the denominator becomes the numerator, and the numerator 1 becomes the denominator, which is invisible 1 here, or invisible over 1 here. So the answer for that one is 1. Now, the fifth property of multiplication of integers is called distributive property. So, distributive property states that multiplying a sum by a number is the same as multiplying each addend by that number and then adding the two products. So, example, we have negative 3 multiplied with negative 4 plus 5 is equal to negative 3 times negative 4 plus negative 3 times positive 5. Let's see if this one is equal to the right side. Again, distributive property states that multiplying a number by the sum will result to multiplying the number to each addends, which is this one, negative 3 times negative 4, negative 3 times 5, and adding the two products will result with the same answer. So let's try to see now. Negative 4 plus 5 is 1. That is multiplied with negative 3. Negative 3 times 1 is negative 3. How about on the right side? Negative 3 times negative 4 is negative 12. So why is it negative 12? Because you multiplied the same signs or like signs. So multiplying like signs will result to a positive number. So again, negative 3 times negative 4 is equal to positive 12. So why is it positive 12? Because you multiplied like signs. Like signs, which is negative times negative, will result to a positive number. Plus, so that's a positive 12, plus negative 3 times 5, that is equal to negative 15. Why is it negative 15? You multiplied unlike signs, a negative number and a positive number. When you multiplied unlike signs, that will result always to a negative number. So we have negative 15. Why is it 15? That's 3 times 5. So 12 plus negative 15, the answer there is negative 3. Why is it negative 3? When you add unlike signs, you will subtract the numbers. So 15 minus 12 is 3. Now, why is it negative? It is negative because the highest absolute value number from 12 and 15 is 15. And 15 has a negative sign. So we will copy the sign of 15. So we have negative 3 as the final answer. Now, as we can see, the left side is negative 3 while the right side is also negative 3. So they have the same answer. That is distributive property. Next is, or the last property for multiplication of integers is the zero property of multiplication. So, zero property of multiplication states that the product of 0 and any number is always equal to 0. So, any number multiplied by 0 is always equal to 0. Like 1 times 0 is 0. 1/2 times 0 is 0. 1,000 times 0 is still 0. So those are the properties of addition and multiplication of integers. Next topic is the conversion of fraction into decimal. So let me show you on how to do the conversion of fraction into decimal and its vice versa, which is decimal to fraction. So let me show first fraction to decimal. Example of a fraction is, let's have 1/4. Let's convert this one into decimal. So first thing is we write this one in this way. One is the dividend, which is placed inside this one, and 4 is the divisor. Next, we will start dividing. So 1 is smaller than 4, so we will add another 0 beside 1. So 1 becomes 10. But first, in between 1 and 0, we should place a decimal point. And while placing the decimal point here, we will also place a decimal point above. Next, 1 becomes 10. So 10 divided by 4 is 2. And 2 times 4 is 8. So the result of this one will be subtracted. 10 minus 8 is 2. Next, 2 is still smaller than 4. So if it is smaller than the divisor, we will add another 0. So bring down 0. So 2 here becomes 20. Now 20 is now greater than 4. So we can continue dividing. 20 divided by 4 is 5. How did I get 5? How many 4 are there in 20? So there are 5 4s. 4, 4, 4, 4, 4. There are 5 4s, and that is equal to 20. Next, 5 times 4 is 20. Subtract them. 20 minus 20 is 0. The answer, or the decimal form of 1/4 is equal to 0.25. So 1/4 is equal to 0.25. How about decimal to fraction? Let's show the reverse process of 0.25 to 1/4. So if the given is 0.25, a decimal number, let me show you how to make this one a fraction. So it is much simpler than the fraction to decimal process. First, write the number that is on the right of the decimal, which is 25. Next, place a bar under 25. This bar is called vinculum. Again, this fraction bar here is called vinculum. So the mathematical term for the fraction bar is vinculum. So 25 over, first place 1. Next, the number of zeros depends on the number of jumps from this position of the decimal point going to the rightmost. 1, 2. So there are 2 jumps. It means we will place 2 zeros. Now we have 25 over 100. If the fraction is still reducible, write the reduced form of that fraction. So 25 over 100 is reducible. So we will get the common factor or the common divisor to both numerator and denominator. the common divisor is 25. So 25 divided by 25 is equal to, that will be equal to 1, while 100 divided by 25 is still equal to 4. So 0.25 is equal to 1/4 in fraction form. Let's have another example in conversion of fraction into decimal or decimal to fraction. Another example is 7/10. So first, to make this one decimal, we will divide 7/10. The numerator is placed inside, which is here. It becomes the dividend, and then the denominator becomes the divisor, which is placed outside. Next, because 7 is lesser than 10, we'll start placing decimal points. So that becomes 0 on the left side, and here on the right side of 7 we will place 0. So 7 becomes 70. Because it is now greater than 10, we can proceed on dividing. 70 divided by 10 is equal to 7. 7 times 10, that is equal to 70. So subtract 70 minus 70, that is equal to 0. It means 7/10 is equal to 0.7. Let's do the reverse process. Let's show that 0.7 is equal to 7/10. So with the same process, and number 1, first write the number on the right side of the decimal point, which is 7, as the numerator. So write the vinculum or the fraction bar. Next, place 1 in the denominator, and then place 0 with the number of jumps from the decimal point to the rightmost part. So the number of jump is 1 only. So the number of zeros in the denominator is 1. So we have 7/10. So 0.7 is equal to 7/10. So let's have another example. So here, our fraction is a mixed number. So a mixed number is composed of a whole number, example 2, and a fraction. So our fraction here, example, we will have 9/100. So this one is an example of a mixed number because we have a whole number plus a fraction. So let's try to convert this one into a decimal. First, 2 is a whole number. So it means we will have 2 point and a decimal 1, or a decimal part. Our decimal part here comes from this fraction, which is 9/100. Now we will divide 9/100. Our 9 numerator is the dividend, while 100, the denominator, becomes the divisor. 9 divided by 100. Because 9 is lesser than 100, so we'll start writing decimal points. Right? 0, 90 is still not greater than 100. So, we will again write another 0. So, by the way, above 9 we should place 0 there, and also above 0 we will also place 0. Why? Because they are lesser than the divisor. So we will directly put 0 above them. Now we have 900. Because we have 900, it is greater than 100, so we can start dividing. 900 divided by 100 is 9. And then, going down, we will multiply. 9 times 100 is 900. And then subtract. 900 minus 900 is equal to 0. So because we have 0 now as the final remainder, so the quotient is our final answer. We have 0.09. So we will write only 0.09 because we have 2 already. So 2.09. Okay? So how about we have a decimal, a negative decimal number. For example, we have negative 3.6. Let's convert this one to fraction. Same with this one, because we have a whole number, it means this one will become a mixed number. So, a mixed number is composed of a whole number, which is 3, and copy the sign, which is negative. So, it becomes negative 3. And a fraction. Mixed number, a decimal number with a whole number becomes a mixed number. Negative 3 and a fraction, which is from 0.6. So 0.6, the number here is 6. So we will write that one in the numerator. Next, in the denominator, write 1. And then start jumping to the right. So we have only one jump. So the denominator will have 1, 0. So over 10. The final answer is negative 3 and 6 over 10. So that's it for quarter 1, week 4. I hope you've learned something, and see you on my next video tutorial. Bye-bye!